Alright, so this is me going through the AP Calculus culminating activity. I had to improvise a little bit. The lens on my Chromebook camera is actually cracked and you cannot see it very well. And also I did everything on paper, not digital, so fantastic. Alright, so this is the test sheet. These are the questions. I'm going to put that off to the side. Alright, so FRQ number 1, this is the answer sheet. So the question is, a particle moves with velocity vt equals 3t plus 4t cosine of t over pi. And that's for the x coordinate, and then the y coordinate is t minus 6 sine of 2 pi t. When t equals 0, the position of the particle is 2 pi squared 5 divided by pi, and you can see that right here. So A, find the position function of the particle and its position at t equals 5. So right here we have the velocity function. We have t equals 0, just the preliminary information at the top of the paper. So question A, the position function. So what we do is the position is the integral of both the x component and the y component of the velocity function. So when we take the x component, or when we take the integral of both of those, we get, for x, we get this ridiculously long equation right here, 3t squared over 2 plus 4 pi t sine of t over pi plus 4 pi squared cosine of t over pi plus c. Well, we were given the initial that when t equals 0, the position is 2 pi squared for x. So we can plug in 0 for t and we get 4 pi squared. This is the calculator question, so this was plugged into a calculator. We get 4 pi squared when we plug in 0 plus c. We know that we have to get to 2 pi squared, so c has to equal negative 2 pi squared. And that gives us our entire x component of our position function. For y, we have the position function is equal to x squared over 2 plus 3 cosine 2 pi x all over pi plus c. And then once again, because we were given the initial when t equals 0, the y component is equal to 5 over pi. When we plug in 0 for t, we get 3 over pi plus c, so c has to equal 2 over pi. And then that gives us our entire position function right here. The second part of the question also asks for its position at t equals 5. So when we plug in 5 for t, we get our x component as 79.7599, or roughly 79.7599, and then our y component is approximately 14.0915, and that's part A. Alright, part B says, at t equals 5, is the particle speeding up or slowing down in the x direction? So in order to determine if it's speeding up or slowing down, we have to look at acceleration. And because acceleration is the derivative of our velocity function, we took the derivative of the x component and the y component, and we just took the derivative of the x component because that's all it's asking is for in the x direction. We know that if the acceleration at t equals 5 in the x direction is positive, it's speeding up. If it's negative, it's slowing down. So we got, for the x component of acceleration, we got 3 plus 4 cosine x over pi minus 4x sine x over pi all over pi. And then when we plug in 5 for that, we get negative 3.448, and the particle is slowing down in the x direction. So part C says, what is the total distance traveled by the particle from t equals 0 to t equals 7? So total distance traveled is denoted by the integral from a to b of the square root of the first velocity component squared plus the second velocity component squared. So we took the x velocity component, squared that, plus the y velocity exponent, squared that, the square root, and then the entire integral from 0 to 7. Plug that into a calculator and we get 91.0616, and that is the first FRQ done. So the second FRQ right here reads, consider the function f of x equals sine of x. Right here we have that up at the top of our answer sheet, just as preliminary information. Alright, so part A says, find any maximums and minimums between the closed intervals 0 and 2 pi. So to do that, we find the derivative of sine of x, which is cosine of x, and we do a first derivative test. We find all the zeros of the first derivative, which in this case is only pi over 2. And then we have to create a sign chart in order to determine the maximum, if it's a maximum or a minimum or neither. So pi over 2 at this point actually ends up being a maximum because it starts off positive, hits 0, and changes to negative. But then we also have to consider the endpoint since it's on a closed interval. 0 is a minimum because directly after the endpoint, the function begins increasing, and then pi is also a minimum because directly before the function, or directly before the point, the function is decreasing. So we have two minimums at 0 and pi, and then a maximum at pi over 2. Alright, part B says find the points of inflection and any concavity changes from 0 to pi. So in order to do points of inflection and concavity, we actually look for the second derivative, and the second derivative of this is negative sine of x, and the points where that equals 0 are 0 and pi. These would be our critical points, but they are not points of inflection because while f double prime of x equals 0 at those 2 points, they are endpoints and do not switch signs, so they can't be points of inflection, which also means that there are no concavity changes. Point C says on the interval 0 to pi over 2, there is a point of C where f prime of x equals c. Find the x coordinate of point C. So this is actually referencing the mean value theorem, and that says at some point on an interval, the average rate of change along that interval equals the derivative at some point in that interval. So we looked for the average rate of change. We did sine of pi over 2 minus sine of 0 divided by pi over 2 minus 0, and we got 1 minus 0 over pi over 2 minus 0, which is 1 over pi divided by 2, which simplifies down to 2 over pi, and that would be where our point C is. Alright, so on to the multiple choice questions. So the first multiple choice question, a fire engine's ladder is 60 feet long and rests against the side of a building. The truck begins to back away from the wall at a rate of 6 feet per minute, and the ladder starts sliding down. At what rate is the ladder falling when the base is 25 feet from the wall? And actually, you literally couldn't see that the entire time I was talking, but it's right here. So I'm going to find my work for this right here. And we can see I drew a diagram. I denoted that what we have is the rate as it's moving away from the wall, which is 6. And then we want dy dt. We want the rate that it's falling down from the wall. So I started off by using Pythagorean theorem. We wanted it when x was 25, so I plugged in 25 for x. We don't know y. And then 60 is the length of the ladder. And we got y equals, or y is approximately 54.544. And then I took the derivative, the derivative of the Pythagorean theorem, and I got 2x dx dt plus 2y dy dt equals 0 because, it equals 0 because it's equal to a constant. 60 is going to stay the same throughout the equation. And then I plugged in what we had so far, so 2 times x, which we want 25, times negative 6 because it's moving away from the wall, plus, or actually not negative 6, it's positive 6, plus 2 times our y, which we got up here, is 54.544 times dy dt, which we don't know yet. We simplify all of this down, get dy dt by itself, and we get that equals negative 2.75, which makes sense because it's falling down the wall at that rate. Over here, that's answer D. It's feet per minute because that's that's the notation that the question is using. B says 2.75 feet per hour, which would be incorrect. So the second problem says solve the following differentiable equation. dy dx equals 7x sine squared sine squared of pi y over 2. So we would start by getting all of our y and dy and then x and dx on the same side. So you get 1 over sine squared of y dy equals 7x dx. You take the integral of both sides and you get negative cotangent of y is equal to 7 over 2 x squared plus c. And then you can see over here that is, it looks like it's answer B. The other ones are incorrect. It's not tangent on the left side of the equation. It's negative cotangent on the left side of the equation, not positive. And then part C has 7x squared, but not divided by 2. The third multiple choice question asks, find the length of f of x equals sine squared of x from negative pi to pi. So the work for that is right here. The length formula is the integral from your starting point to your ending point, the square root of the square root, 1 plus, and then the derivative of your function. So the derivative of sine squared is actually 2 sine of x cosine of x, and then that squared inside the square root. You can plug that into a calculator and you get roughly 7.6404, which is option B on the actual test. The fourth multiple choice question just says evaluate, and then it's the integral of 7x sine of x over negative cosine of x dx. So it's right there down below. I actually used u substitution for this. I said let u equal negative cosine of x, which means du dx is sine of x, which means du is equal to sine of x dx, and then dx is equal to du sine of x. So then you plug it back into your formula, you get 7x sine of x over u times du sine of x. The sine of x's cancel and you're left with 7x over u du. You just take the antiderivative of that and you get 7 over 2u x squared plus c, and you end up getting, well, when you plug u back in, so when you plug in negative cosine of x back in for u, you get 7x squared over negative 2 cosine of x plus c, and then over here on the exam, that looks to be, that's sine of x, so that's incorrect. There's no negative 2 here, so that's incorrect. This does not have plus c. Can't put my name on the board still, Mr. Boothman. And then it looks like it's a, so 7x squared over negative 2 cosine of x plus c. And that should be the end of the exam. Thank you.